The climate crisis is also top of mind for many voters. The Mississippi River is at historically low levels, which could impact the food supply and our wallets.
For over 150 years, the Mississippi River has been one of the most closely tracked rivers on Earth. Entire cities, industries, and farms depend on it every single day. However, in late 2024, scientists began to notice something unusual. Water began vanishing at a rate never recorded before. Rainfall was normal. There was no major drought. And yet barges ran aground, and river levels dropped to historic lows. What made this alarming was not just how much water was missing, but how quietly it disappeared. For a while, scientists had no clue what was happening. The answers began to unfold when scientists started looking not at where the water should have been, but at where it wasn't going. So what is causing the Mississippi to lose water on this scale? And what does it mean for the river and the millions who depend on it? Let's find out. The unusual readings. In October 2024, something unusual began to appear along the Mississippi River near Memphis. Satellite images showed water levels dropping to depths that had not been recorded since measurements first began in the 1800s. Large cargo barges that normally moved freely were left sitting on sandbars, and parts of the river looked more like narrow channels than one of the largest waterways in the world. At first, this seemed like a familiar problem. Low water levels had happened before, often during long dry seasons. But when scientists reviewed the usual causes, the situation did not make sense. Rainfall across the Mississippi Basin was close to normal. Snowmelt from the northern states had already moved through the system as expected. Streams were still feeding water into the main channel. Yet the river continued to lose depth. What made this event different was the speed of the change. Rivers usually respond slowly to shifts in climate or land use. This drop happened in less than 2 years. Historical records show nothing similar, even during past severe droughts. Engineers then noticed something more troubling. Water entering the Mississippi upstream was not arriving downstream in the expected amounts. It was not delayed, redirected, or stored behind dams. It was simply not there. That raised a serious problem. A river is not supposed to behave this way. In a system this large, water cannot just disappear without leaving clear signs. So the question was no longer about low water. It became something deeper and more unsettling. If the Mississippi was still being fed from above, why was so much of its water failing to reach the end of the river? The river tracking system. That uncomfortable reality pushed scientists to look closer at the system they trusted the most. If the river itself was acting differently, the first step was to confirm how its behavior was being recorded. The Mississippi River is measured through a large network of monitoring stations spread along its length. These stations track water depth, speed, and total flow. Many of them send updates every 15 minutes. This is not guesswork. It is a continuous measurement. Some of these stations have been operating for decades. Because of that, scientists can compare today's readings with data from many years ago. They know what normal looks like. They also know what extreme events look like. The basic rule is simple. Water enters the river from rain, snowmelt, and smaller rivers. That water should move downstream toward the Gulf. Small losses happen along the way. Water evaporates. Cities and farms withdraw some of it. All of this is measured and expected. For almost 100 years, this balance held steady. Engineers used it to plan shipping routes and flood control. Cities depended on it to manage water supplies. Even trade markets relied on river forecasts to set prices months ahead. Because this system was so reliable, problems were mostly easy to explain. A broken sensor or a temporary blockage would show up clearly. The stations agreed with each other. Backup checks confirmed the same results. The numbers stayed consistent. The measurements were not failing. They were telling a clear story. The river was losing water, and the loss was real. When the data broke, that clear story raised a new problem because the numbers were now saying something science was not prepared for. The river was being measured correctly, yet it was no longer following the patterns that had worked for decades. Scientists compare water flow at different points along the river. When water passes one station, it should appear at the next after a known amount of time. This delay is well understood. It rarely changes unless something blocks the river or removes water on a large scale. Near Memphis, flow readings showed strong water moving into the lower Mississippi. Based on history, most of that water should have reached Baton Rouge within days. When teams checked downstream, a large portion never arrived. At first, researchers assumed small losses. Evaporation was checked. Human use was reviewed. Tributary changes were examined. None of these could explain the gap. The missing amount kept growing. Each new set of readings showed more water gone than the last. Over time, the loss reached tens of thousands of cubic feet per second. That is enough water to supply major cities every day. Because the numbers were so extreme, scientists tested everything again. Sensors were recalibrated. Different tools were used. Separate teams measured the same sections. Every result matched. The data did not drift or fluctuate. It stayed consistent. This meant the problem was not random. It was part of a system change. The river was losing water steadily. With surface causes ruled out, scientists had to look beyond what could be seen. Whatever was happening appeared to be connected to what lay beneath the river itself. The ground changes. That deeper direction led researchers to the ground beneath the river, where water moves in ways most people never see. If the river was losing water without clear surface signs, then the riverbed itself had to be involved. The Mississippi does not sit on solid rock in many places. It rests on thick layers of sand and gravel. New surveys showed a change. Tests found that the sediments under parts of the river now held much more space than before. This meant they could absorb far more water. The riverbed had not cracked or collapsed. Instead, the sand and gravel had shifted and loosened. Because of this change, water flowing above could sink downward faster than it used to. Over long distances, that loss began to add up. But sediments alone cannot keep taking in water forever. Once they fill, water should return to the river. The consequences. Those underground systems were already under heavy pressure long before the river began losing water. Beneath the Mississippi lies a vast network of aquifers that supply drinking water to cities and irrigation water to farms across several states. For many decades, more water has been pumped out of these aquifers than nature can replace. As groundwater levels dropped, a quiet change took place. The pressure underground became lower than the pressure in the river above. When the riverbed sediments loosened and held more empty space, river water began flowing downward to fill that gap. This process is called induced recharge. It means surface water moves into the ground because pumping has created a strong pull below. The effects spread fast. Lower water levels made shipping harder and more expensive. Barges carried less cargo. Cities felt the strain too. When groundwater use was reduced, many users turned to direct river withdrawals. Restored wetlands held water, but much of it drained underground. Even releasing more water from the dams only sped up the loss through the riverbed. What became clear was that this was not one mistake. It was the result of many small choices made over a long time. The river did not suddenly fail. It slowly changed. The Mississippi River water did not disappear. It changed in ways few expected, and even fewer understand. What we are seeing is not a single failure, but the result of many quiet choices adding up over time. I hope you enjoyed this video. Make sure to give it a thumbs up. Also, consider subscribing to the channel if you haven't already, because we will be uploading more crazy stories like this one in the coming weeks. Until then, see ya!